Hello, friends. So today we'll be looking at problem from LeetCode. It's another problem marked as easy on LeetCode. And the problem says, given two strings s and t, write a function to determine if t is an anagram of s. So what's an anagram? Um, a string, if the letters from that string are shuffled, and you can create another string. The second string is said to be an anagram of the first one if all the letters are the same, but they're just shuffled. They could even be in the same order. So if you see here, the input that we see here is S and T. We need to write an algorithm which compares the two strings and returns an output whether it's true or false based on whether it's an anagram or not. Some of the conditions, it says you may assume that the string contains only lowercase alphabets. There's also a follow-up question here which says, what if the inputs contain Unicode characters, and how would you adapt your solution to such a case? So let's first solve it using the assumption that everything's going to be a lowercase alphabet, and then we can probably, hopefully look at the follow-up question as well. A small note about which companies are asking this kind of question. You see most of the top tier companies like Facebook, Amazon, Bloomberg, Google, Apple, they're asking this question. So I have the code and the algorithm here in Java. I've already written it down. Before we look at this, let's take a visual representation of what this problem really is. So here's the two input strings, S and T. Um, we need to compare both of them. We need to make sure that our algorithm really is optimal in both the time and space complexity. So we have to come up with a solution which does not iterate through both the strings ideally more than one time. So, so that said, how do we solve this? One of the easier ways to do this is really take the first string, for example, S in this case, create a histogram. A histogram really would be an array, since we already know that each of the individual characters in S has to be from the lowercase alphabet. So we know that the histogram that we create to keep a frequency of how many times a character appears in the string cannot be longer than 26 because there's only 26 letters in the alphabet. So what we can do is we create a histogram, we go through each character, and then we update its frequency. Once we have that, then we look at the second string and then go through each of the characters and reduce the frequency of that character from the same histogram. Now, when we do that at each step, we look at the count frequency of that character. If that goes below 0, that means we know that this character, the particular character in T never appeared in S, and it's not an anagram. So let's look at a visual, hopefully this kind of helps. You create a little histogram, basically this is your array of characters. It's 26 length because you have 26 letters in the alphabet. And then what you would really end up doing is go through S and then update the frequency of that particular character. So in this case, if you go through A, it becomes 1. Then you go to N, you have N, which is 1. Then you go back to A, it becomes 2. Then you have G, you update G, that becomes 1. R, A, and M. So this is essentially our histogram at the end of going through the first word. Now you go through T and go through each character and then reduce it, right? So you go to N, you reduce this, make this 0, A would become 2, G would become 0. Now at each step we see if the value at that point, at that particular character goes below 0, that means that this is not histogram. Pretty self-explanatory. Like if you visualize it this way, I think it seems it's quite helpful. At least it helps me. So now to let's go back to the algorithm itself, right? So a couple of edge case scenarios first, right? Um, if s is null, right? Or if s's length is 0, then all we have to do is we have to return whether t is null or length is 0. Because if it's not, then that means it'll be false. Also, another thing to note is if they don't have the same length to begin with, there's no point in comparing them because we know that one or more of the characters don't belong to the other one. So that's essentially our edge case. We check them up front. The rest of the algorithm is pretty self-explanatory from the visual that I showed you before. Um, here's your integer. Here's your integer array, size 26. For each character in S, right? You go in and update the count of that character, right? Once you do that, you go through each character in T, you decrease the count of that character, and at the same time, you make sure that it's not less than 0. Because if it is, then you return false right away. If at the end of this loop, you've gone through each character in T and you found a matching character in the integer array, that means it was an anagram, and then you return true in the end. So pretty straightforward once you kind of visualize it and think about it from a frequency of characters point of view. Um, Now quickly, looking at the follow-up question, right? What if the inputs contain Unicode characters? What if it could have, other characters? What if it's, how do you adapt your solution? So one comment that I would have is instead of having a fixed length array, we could change this to a hash map, right? The hash map, the key would be the character itself, and the value would be the count of times that it appears in your first string. So instead of this array, you would have a map. You would do the same thing. You would go in and update your map here, and then go through the second string, reduce the count. And at each step, you would say if the count of that particular character in the map goes below 0, you return false. So that should probably be a satisfactory answer for this follow-up question. Hopefully this was helpful in visualizing it and understanding this algorithm. And hopefully, if you see this in your next interview, you might this visual might help you um, work through it and give a good answer to your interview. So hopefully like this, I'll continue making more videos. Let me know if there are any other problems that you want me to work with. Right. Bye.